Welcome to LINAK's Actuator Academy video series for industrial actuators. I'm Hunter, and today we're going to talk about an I/O actuator's protection features, one of several options configurable within the Actuator Connect configurator for LINAK's I/O interface. The protection option helps you prevent damage and breakdowns by protecting your application from improper use. Several features can help you achieve the optimal performance out of your application. Before we look at the protection features, I'd like to introduce the latest current limiting algorithm that we've developed for our I/O actuators. The current limiting algorithm describes the way the actuator responds to an obstruction, so how it detects it and how fast it responds to it. If the actuator's current consumption rises above the set limit, the actuator regulates and tries to keep it below the set current by means of PWM. The actuator does this continuously until the actuator stops moving, determined by monitoring the Hall feedback signal. If there are no Hall pulses during a set time frame, the actuator stops. If the actuator stops due to an obstruction, it automatically drives slightly in the opposite direction to reduce the force in a blocking situation. The reverse drive distance depends on the chosen spindle type in the actuator. Ultimately, it offers the ability to limit the current consumption to a level that matches the application requirements, thereby protecting both the actuator and the equipment it's mounted in. Now that you know the basics behind our current limiting algorithm, let's continue with the current limit feature. If we open the Actuator Connect configurator, Current Limited is the first tab found on the protection screen. Current limits can be configured to avoid crushing when meeting an obstacle. The I/O actuator comes with pre-configured current limits, but these values can be adjusted according to your preferences. The current limits are divided into two options, standard or advanced, depending on how much fine-tuning is required throughout the stroke length. With standard, you can adjust current limits in both directions with fixed values. For advanced, you can get full control of the actuator with 10 variable current limits in both directions. For standard current limits, you can define a new current limit that ensures the actuator automatically stops if it hits an obstacle or meets another resistance in the application, which is designed to help protect both the application and the actuator. Current limits can be set in both directions, and these limits can be configured to specific values above and below the reference temperature of 0 degrees C to allow increased power consumption when low temperatures are present. Under Advanced, for more specific needs, you can define up to 10 variable current limits in both directions and with the possibility to set specific values above and below the reference temperature. This is done by dividing the stroke length into intervals of 10% and setting a unique current limit for each interval. This is especially convenient when you'd like specific segments of the movement to have their own unique current limit. This gives you full control of the actuator and a more advanced way of managing current limits. When manually adjusting current limits, it's important to consider varying the values above and below the reference temperature of 0 degrees Celsius. In colder environments, the energy consumption of the actuator will increase due in part to the increased viscosity of the grease in the actuator. To ensure maximum performance and avoid an unintended current cutoff from a cold start scenario, it's recommended to take this into consideration when adjusting the current limits. Keep in mind that the current limits are not intended for use as a general stop function, since this can stress the mechanics and reduce performance over time. LINAK also offers start and stop settings like ramp up and ramp down as an alternative to instant stop. With ramp up and ramp down, the actuator slowly accelerates to full speed when starting movement or slowly decelerates from full speed when stopping. With this feature, you avoid bouncing and achieve smooth operation. You can choose to go with LINAK's default settings, or you can go with your own ramp speed settings. This feature provides smoother movement and reduces strain on the application, significantly extending the service life of the actuator. Traditionally, soft stop occurred after the signal had been removed, and it would continue to run. As an extended feature, you can now choose ramp down towards an end stop, which ensures that the actuator always decelerates directly to the physical or virtual stop. In some cases, there may be external factors that need to be in place before the actuator can run. You can use a third digital input as an external precondition to allow this movement. A signal from a sensor can be connected directly to the actuator to verify whether these conditions are established before it runs. Imagine a garbage compactor, where garbage should be compressed only when the lid is fully closed. Here, one actuator could be used to open and close the lid, and the in-stop signal from the lid actuator could be used as a run condition for the second actuator that compresses the garbage. Solutions like this can reduce the complexity of your PLC, and in some applications could potentially save you extra components.